Hi friends, my name is Mufid. I'm from the Indian Academy in Dubai. Today we'll be explaining how to perform the metre bridge experiment as a part of a video library for physics practicals. The materials required for the experiment are a plug key, a resistance box, a galvanometer, a power supply, a meter bridge, a jockey and an unknown resistant wire. To start off, set up the circuit as shown. Make sure the wires are connected properly across the circuit. Turn on the power supply. Once you fix the voltage, don't change the voltage. Insert the key in the plug key. Tighten the keys in the resistance box. Using the jockey, press on points A and B. If the galvanometer's reflections are in opposite directions, then the connections are correct. To introduce resistance to the meter bridge, remove few number of keys required. Using the jockey, find the point in the meter bridge where the galvanometer reading shows 0. Measure the distance from the point A and write it in the column L1. Find distance L2 by subtracting 100 from L1. Then calculate the unknown resistance X is equal to L divided by 100 minus L multiplied by R. Repeat this process with different resistance by taking out more keys from the resistance box. Use another wire, find its resistance using the same method.
Hi friends, my name is Prince. I am studying in Indian Academy, Dubai. Today I will be verifying the laws of series combination of resistance using a meter bridge. The theoretical value of series combination of resistances R1 and R2 can be calculated by using the formula Rs is equal to R1 plus R2. Connect two resistances R1 and R2 in series combination. Switch on the battery. Remove some keys from the resistance box and insert the plug key. Press the jockey against the meter bridge until the galvanometer deflection shows 0. Note the reading from the meter bridge in the observation table's column, length AD. Calculate the length DC by subtracting the observed length by 100. Calculate the unknown resistance by multiplying the used resistance with length AD divided by length DC. Repeat the same procedure by using different resistances by removing different keys from the resistance box. Calculate the mean resistance Rs and this value obtained will be the experimental series combination of resistances.
Hi friends, my name is Madhur Sahu and I'm from the Indian Academy, Dubai. Today I'll be verifying the law of parallel combination of resistance using meter bridge. When two resistors R1 and R2 are connected in parallel, the resistance of combination Rp will be 1 by Rp is equal to 1 by R1 plus 1 by R2. Connect the two resistances in parallel combination. Switch on the battery. Remove some keys from the resistance box. Insert the key in the plug key. Press the jockey on the meter bridge. Make sure there is deflection on both the sides in the galvanometer. Find the point on the meter bridge where the galvanometer shows 0 deflection. Note the reading from the meter bridge on the observation table under length AD. Calculate length DC by subtracting length AD from 100. Calculate unknown resistance by multiplying known resistance with length DC divided by length AD. Repeat the process by using different resistances. Find the mean resistance with the obtained value.
Compare the theoretical values of Rs and Rp with the corresponding experimental values. If theoretical value Rs R1 plus R2 is approximately equal to experimental value of Rs and theoretical value of Rp R1 R2 divided by R1 plus R2 is approximately equal to the experimental value of Rp, then the laws of combination of resistances in series and parallel are verified.